Hi all, we're going to work on manually adding joints to this clamp example that Fusion 360 comes with to teach us about assembly modeling from different components, bringing them together to do the mechanical animation. Here we go. The prerequisites tell us what we need to do to start. We need to make a new project and call it manual joints. Okay, so we'll start with that. We'll try to follow the steps step by step as a way to practice following written instructions. I'm going to go to File and saving my empty project. And here I'm going to go into New Project, and this was called Manual Joints. Okay, and now in the location, I'm going to find Manual Joints. There we go. And maybe it has a name for me. I'll just call this my assembly here. So now I created a new project and I saved an empty file. The next thing that it's going to tell me is to open up base, clamp, connector, grip, lever, and shaft from the basic training 06 assemblies folder from the data panel. Here I go. Basic training, assemblies, and I can find these things. It asks me to open them. Opening the base, the clamp, the connector, the lever, the shaft, and the grip. And it's asking me to save each of these into my manual joints project. So I can hit Control S. Maybe not, save as, there we go. And it's going to put it right into the manual joints project. The reason I need to do this for all of them is because they're read-only, because they're from the samples. So that's 2, this is 3, this is 4, 5, there's the base. Okay, and then here's the empty file that I created initially. Close each of the parts, open the manual joints project to open it and ensure the files are in the project. So now I'm going to go to the manual joints project. Making new projects as you go is a good idea to keep things organized. I've got the assembly, which is the empty one, and then 1, 2, 3, 4, 5, 6 parts. Okay. Double click on the manual joints project, open it, we did that. Ensure a new untitled design is open, and they're asking us to save that one, so we've done that. So we're going to assemble the clamp and add the joints. Insert the base into the clamp joints design and ground it. Okay. Insert the base into the design. There it is. And I'll ground it. I'm going to right click on it as a component, and I'm going to go to ground. This prevents it from moving whatsoever. It's got 0 degrees of freedom. Insert the lever and use a revolute joint to attach it to the base. Here's a lever. Okay. Now before I finish adding it, I'm just going to move it over so that I can see more easily the parts that I know that I need to use. Referencing the picture, I can see that I need to use this part of the rod of the lever into those 2 circles. So I will do that now. I'm going to press S and I'm going to type joint. We're using a joint and not an as-built joint because we need to move this component to its final destination. Okay, I should be able to access, as I hover over the center of this joint origin here, so clicking on that component. And then here, it's going to go into the center of this cylinder. So I'm rotating my screen around, and I can see I can't access that center origin. So I'll hover my mouse here, I'll hold Control, and while holding Control, I can access it. Perfect, that's what we needed. Okay, looking at the picture, I noticed the difference is that ours is not flipped, so I'm going to right click and edit this joint from the design timeline. I'm going to click on flip and hit OK. Perfect. Now it's the same orientation. I'm going to edit the joint one more time, and I'm going to go to motion, and I'm going to make it a revolute joint, because before I had it as a rigid joint because I was rushing and not paying attention. There we go. My picture looks the same. Create a joint origin midway between the open holes on the lever. Okay. So here it's asking me to make a joint origin because there's probably not one where we need it to be. So in between these two holes here, I'm going to make a joint origin. All right. I'm going to make a joint origin. Joint origins are snapping points that we can use for mechanical animation. I will capture the position of that arm movement just for convenience. A new joint origin is going to be between two faces. And it looks like we're going to have to follow the instructions a little bit more closely. Here we're actually opening. So we're going to this lever and we are opening it. Now we can make a joint origin. Between two faces, between this face and this face. And our snapping point would be here. Looking at the final result, this is a new joint origin between those two faces, snapped along the axis of these cylinders. Okay. Now I can close it, save it, click on this icon to reload my design, and now I've got a fancy new joint origin right where I need it. Okay, so here it was telling me select the edge of one of the holes to define the joint origin. Check, we did that. Prepare to add the connector to the camp joints origin design. That should say clamp. Go back to the clamp joints design. In the clamp joints design, the lever is out of date. We fixed that. Get latest, we did that. Insert the connector and use a revolute joint to attach it to the lever using the joint origin created. So we're adding the connector and we're attaching it to that new joint origin, just like this. Here's the connector, dragging it into the design. As a matter of convenience, moving it out of the way for a moment and hitting OK on that move command. Creating a joint, going between this joint origin that we had created and the center of this cylinder. Now it's moved this as a preview. That's okay because this part is grounded, so it will all get calculated out as needed. This needs to be a revolute joint, not a rigid one, and we'll hit OK. All right, so now we've got this part functioning as we would expect, and it looks like the picture. Insert the shaft and use a cylindrical joint to attach it to the base. The cylindrical joint allows the part to rotate and translate around one axis. Insert the shaft. Okay, and it looks like I need to attach the shaft here to there. We'll make a joint between the center of that cylinder and make it a revolute joint. And then we'll tell Fusion we're looking at the next snapping location right here. Okay, so that's not the degree of freedom that we needed. Let's try it again. Let's grab this piston and let's grab the center of this again. Okay, perfect. Changing it, making sure that it's revolute and hitting OK. Here, Fusion is asking me to create the cylindrical joint between the shaft and the empty cylinder here. So we've skipped ahead and we've done the revolute joint. Let's also add the degree of freedom that will lock this inside that area there. So create a joint and we're going to change it to cylindrical. It's nice to change the joint type first so that you can tell Fusion what to expect. We want this part of the cylinder to go into that part of the base. Okay, easy. Now when I move the handle back and forth, the shaft can spin freely on this rod, and it can slide back and forth along this axis, just like that. Okay, so we've completed that revolute joint, and our part looks like this now. Insert the clamp and use a ball joint to attach it to the base. The ball joint allows the part to rotate around 3 axes. There's our clamp. Okay. And it was asking me to use a ball joint. We use a ball between the center of the sphere and the center of the sphere. Okay. Now the clamp, let's bring that back a little bit. The clamp can rotate freely around the ball joint. We haven't created the limits for this joint, so that's okay. I don't mind that that's happening. Here we will just simply revert the original position. Okay, so that works as intended so far. There's our ball joint. Join the grip to the lever with a rigid joint. We'll click on the grip design in the data panel. Okay, we'll insert the grip. We'll do this part a little bit slowly because I think there might be a trick to it. There's our grip. Click solid, assemble joint, and set the motion type to rigid. Okay, so we're making a rigid joint. If you get a dialog indicating components have moved, capture position, click on the inside grip face, but not on any snap points. This limits the selection of snap points to only the ones on the face. Clicking on the inside of the grip, and now our selection is limited only to these joints, joint origins. Click on the snap point that represents the center of the radius on the top of the grip. Okay, this is the center of the radius on the top of the grip. Click on the center of the lever handle radius. That should say that corresponds to the grip location. You select it and click OK. Okay. So I've clicked it on that face, so this should really be right here. Ensure the grip is properly assembled to the lever. Well, it's not. So what should we do? Let's see if flipping it changes anything. No, it doesn't, because that just flips the face there. I want to rotate this a little bit to repair it. This is called a joint alignment, and that's no problem. You can fix it just like that. Perfect. Okay. So that's the end of the tutorial. We can check out our final motion when we click on our handle. There we go. Now, as a bit of a bonus, because we find that this handle goes too far to where it should be, and the handle is really the input to the chain of motion, we should limit the motion of the handle so that it can't go any further than what would be physically possible, somewhere around here should be our maximum. So thinking about the joint that controls specifically the motion of this handle, it's this revolute joint. So we're going to right click on it, we're going to edit the motion limits, and we're going to use the minimum and maximum there we go, limits to restrict the overall motion of this joint. So we're going to say it can go as far as here. And we might have to check to see the consequence of this, but let's try here. We can preview just the handle, but we'll have to hit OK and see what happens. Now, I can't physically drag the handle beyond our limit, and I also can't push it further than our limit. I'm going to edit this one more time, edit motion limits, because I think that it really should be even further now that I see it. Okay. There we go. So I can't push the handle further forward. I can't push it further back. That's good. That's what I wanted to check on. That's the completed tutorial.